Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzatman. I will present to you my group presentation for subject Bmmm 3523. Assignment for my section Bmmm 1/2 for 2022 about ultrasonic monitoring. So here is our list of name of presenters. Firstly is Muhammad Faiz Hakim bin Muhammad Fauzi. Second is Muhammad Alif bin Adam. Next, Muhammad Ayub bin Muhammad Sofi. And Muhammad Iqbal bin Bulmeng. And lastly, my name is Muhammad Izzat Iman bin Zulkarnain.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faiz Hakim bin Muhammad Fauzi. I will present about introduction. Ultrasound inspection has a unique position in condition monitoring as a stand-alone inspection technique as well as an effective training tool that may help inspectors decide appropriate follow-up activity for mechanical, electrical and lead applications. Whether proactive inspectors are referred to as predictive maintenance or condition monitoring. The goal is the same: to identify a deviation from a normal or baseline condition in order to determine whether or not corrective action should be taken in planned, orderly manner and to avoid an unplanned incident. For objective: first, effective screening tool that can speed up the inspection process, and second, help inspectors determine effective follow-up action for mechanical, electrical and lead applications.
Okay, Assalamualaikum. My name is Muhammad Alif bin Adam. I will present about what is a predictive maintenance. So, predictive maintenance is a technique that use condition monitoring tool and technique to monitor the performance of a structure or a piece of the equipment during operation. Predictive maintenance is a type of a condition-based maintenance to monitor the condition of the asset using the sensor device. This sensor device supply data in a real time, which is used to predict when the asset will require maintenance and prevent equipment failure. Predictive maintenance refers to the use of the data-driven proactive maintenance method that are designed to analyze the condition of equipment and help predict when the maintenance should be performed. Overview: ultrasonic analysis can be used for the leak detection, mechanical inspection, electric inspection, electric arc flash detection, steam trap maintenance and valve testing. So here we provide the type of maintenance. So we go the first, vibration analysis. This is go-to type of analysis for predictive maintenance inside the manufacturing plant which high rotating machinery, because it's been around longer than others type of the condition monitoring. It's relatively cost effective, and in addition to detecting looseness like in the example above, vibrational analysis can also discover imbalance, misalignment and bearing wear. So second type is a acoustical analysis, focus to the sonic. This type of analysis required less money to the implant and it used for the low and high rotating machinery. It's particular popular among lubricant technician. This type similar to the vibration analysis, however, its focus is not to detect cause for rotating equipment failure by measure and monitoring vibration at discrete frequencies and recording data for the training purpose. So we go the third type of predictive maintenance is acoustical analysis, focus to the ultrasonic. Ultrasonic acoustical analysis is solely used for the predictive maintenance effort, and because it can identify sound related to the machine friction and the stress in the ultrasonic range. It's argued that this type of analysis predict imminent breakdown better than vibration or oil analysis. And last is infrared analysis. This type of analysis is not dependent on the asset rotational speed and loudness. Therefore, infrared analysis is the most cost-effective tool for the predictive maintenance. It's often used to identify problems related to the cooling, airflow, and even motor stress. Point is why important predictive maintenance. Predictive maintenance allow for the safety, compliant, and preemptive corrective action and increase asset life. By looking ahead and knowing that what failure is likely to occur when the preemptive investigation, maintenance schedule adjustment and repair can be performed before the asset fail. So, a good predictive maintenance program can prevent unexpected failure, downtime, and waste. Ultrasonic technology provides an efficient and cost-effective method for the monitoring critical equipment. Frequent inspection, documentation, and a trending are crucial for the effective predictive maintenance program. Some of the main components that are necessary for the implementing predictive maintenance is data collection, pre-processing, early fault detection, time to the failure prediction, and maintenance scheduling and resource optimization. On average, predictive maintenance increase productivity by 25%, reduce breakdown by the 70%, and the lower maintenance cost by the 25%. It is based on the advanced analytic and mark a new way of organizing and implementing maintenance on an industrial case. Maintenance workflow. The graphic below outlines the predictive maintenance workflow from start to the finish. The ultimate goal with a predictive maintenance is to catch breakdown before they happen by the monitoring equipment. So here we got 4 steps. First, starting. Second, establish baseline. Third, install Internet of the Thing device. Third, connect device to the software. And 5, schedule maintenance. So we go the first step is establish baseline. The maintenance team establish acceptable condition limit for the asset that will have a sensor. Number 2 is the install Internet of Things device. The relevant sensor is affixed to the asset. For instance, a vibration meter is affixed to the mechanical asset with a gear, and a temperature sensor is attached to a boiler. Step number 3 is a connect device to the software. The IoT device is connected to the CMMS or remote dashboard where the data is collected and analyzed. And last is a scheduled maintenance. Inspection automatically triggered by the CMMS when the condition limit is the exceeded or the person monitoring the dashboard schedule the inspection manually.
Assalamualaikum and salam sejahtera. My name is Muhammad Iqbal. I will present about inspection methodology. In ultrasonic testing, an ultrasound transducer connected to a diagnostic machine is passed over the object being inspected. The transducer is typically separated from the test object by a couplant such as a gel, oil or water, as in emission testing. However, when ultrasonic system testing is connected with an electromagnetic acoustic transducer EMET, the use of couplant is not required. There are two methods of receiving the ultrasound waveform. First is reflection and second is attenuation. So in reflection or post-echo mode, the transducer performs both the sending and the receiving of the pulse waves as the sound is reflected back to the device. Reflected ultrasound comes from an interface such as the back wall of the object or from an imperfection within the object. The diagnostic machine displays this result in the form of a signal with an amplitude representing the intensity of the reflection and the distance representing the arrival time of reflection. In attenuation or through transmission mode, a transmitter sends ultrasound through one surface and a separate receiver detects the amount that has reached it on another surface after traveling through the medium. Imperfection or other condition in the space between the transmitter and receiver reduce the amount of sound transmit, thus revealing their presence. Using the couplant increase the efficiency of the process by reducing the losses in the ultrasonic wave energy due to separation between the surface.
Hi, my name Muhammad Ayub bin Muhammad Sofi and I will present application of the equipment with appropriate example used in industry. Number 1, compressor valve leak detection. It is a method of determining which valve to change, reduce the manpower requirement, and it can detect precisely what are broken in the valve. Number 2 is manpower transformer anomaly. It is an ultrasonic scan of both the inboard and outboard bearing on several transformer oil pump of the same age. It is decibel reading on the oil pump inner and outer bearing give the ultrasound operator excellent information about what might be cause the higher temperature reading on the top of the transformer and subsequent high gas reading. It is also can be used to help evaluate risk of going to higher load. Number 3 is electrical inspection. It can detect ionization produced by etching, tracking, and corona. Can be used to locate problem in all voltage with the majority of application in the mid to high voltage range. Its sound sample can be recorded for analysis and spectral or time series view placed in reports. Number 4 is leak detection. Leakage can occur in liquid or gas system, pressurized and vacuum system, internally, which is in valve or behind the wall, or externally, which is through exposed piping. It is also a way of keeping a system running more efficiently. And as part of the energy conservation program, it is also for safety purpose or to reduce an environmental impact. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I will present you about a barrier in predictive maintenance implementation in industry. First barrier is a barrier to using technologies. Manufacturer companies are optimized for a floor assembly of materials. They are not traditionally expert in conditioning, monitoring, and or data analysis, and we don't believe they should have to be. Until recently, successfully predictive maintenance has required either deep pockets for external consultant and or a team of experienced in-house condition monitoring experts. Secondly is financial justification. A paradigm shift in maintenance approach can be difficult to initially justify, given a fear of unknown and the belief often misplaced that what we have works. Adopting predictive maintenance does require an initial outlay, but looking at the short-term view must be discouraged. Successfully predictive maintenance is continuously demonstrated as saving upward of 20% of operations and maintenance costs. Third is cultural fit. Maintenance can often be seen as a firefighting activities, with facilities managers doing the absolute best they can in situations where they are given little to no warning of impending disaster. There is a justifiable fear that that changing anything at all could lead to future problems. This is why it's absolutely key that any predictive maintenance program is introduced slowly and that the benefit to everyone can be clearly and consistently demonstrated.
For conclusion, ultrasound condition monitoring provides many opportunities to improve asset availability, keep production on schedule, and save energy. Application of mechanical analysis, electrical inspection, and leak detection cover just about all plant equipment. The basic ultrasonic instruments are relatively easy to use, while advertisement in the technology have helped improve data management, analysis, and reporting. With escalating energy costs, ultrasonic technology can provide a cost-effective approach to reducing energy waste in compressed air and steam systems.